Thank you for the introduction. So, I am a data scientist. I have been a data scientist for 4 years now, after doing that kind of a job for 2 decades. You know, data scientist is supposed to be the sexiest profession in the 21st century. So it reads in a magazine. It's a unicorn-like thing, you know. We are doing such wonders as in Westworld. You know what's common with unicorns and Westworld? It's that they are fairy tales. But data scientist, that's a decent profession. It's nothing more than a new discipline proposed by Professor Cleveland around year 2000. The problem was that statisticians were falling behind in technical excellence. He wanted to create a new curriculum of combined computer science and statistics. There are databases, lots of computing power. Machine learning is an old thing. The first machine learning program was written year 1959 by Samuel at IBM. It's learned to play checkers. So it's in a retirement age, the machine learning. So what we wanted to share with you, with my colleagues, we gathered a couple of years ago 6 PhDs in data science to think that what we wanted to tell about our field. You might think that we would like to tell about fancy algorithms and that sort of stuff. Well, we know those. That's our profession. But we were discussing about the organization and culture, why we get stuck in the projects. We are doing this together, and after presenting some things that we do on a daily basis, we are going to go to the culture thing. Our playground is here. Hanna showed kindly already that AI is super important and there are lots of applications. So I have not to do that, but I'm just telling what we do. And there is a big division basically in our work. The one side is analytics, even BI, statistics, getting information out of data and experiments for people, for public, for politicians, for managers, for directors, for everyone. Information to make decisions. The other branch, well, that's something that you may call AI or automation. We make machines that make decisions, artificial intelligence even. Why this is important? Because you need different competencies for making this sort of stuff. It's a different story to get information for people or make artificial intelligence. So, just to show that what we might be doing, I'll show a demo on our daily bread. We are not going to the high-end AI like AlphaGo, nor to making reports, but let's take recommendation engine. You predict things to be shown, proposed to people in media or in web shops. Why? To increase revenue, to make people happy, to personalize. For that, you require some sort of machine learning or statistics. And I'll go for a topic first that interests or should interest everyone, the politics. You know, there are voting advice applications. It means that media companies often have pre-election this sort of questionnaires for politicians. They answer to multiple choice questions, and you can answer to the same questions, and then what it does, it recommends you a candidate. We all know this. This is from the last municipal election in Finland, year 2017. I haven't done this, but Wiley, the Finnish broadcasting company, gives the data from this application from the candidates, not from the public, from the candidates openly. So you have open data. And I spent some hours and days making this sort of demonstration on the data for you. When you start data science, you often think that, okay, let's go through the data and see about that. When you do things, you have to start from the point of asking why, what it is for. So what do we use this for? Well, you should be asking, why do we recommend? In what context? For whom? What is our hopes for the accuracy? How do we measure that? Based on what data? I'm going to skip this as lightheartedly as it's unfortunately done in real projects too often. This is an infotainment thing, so I'm going to show some things that you could be doing with this data. You could do a web application based on this, basically. But what I'm going to recommend here, I'll skip the candidate based on multiple choice questions, that's already done. But I'm going to recommend a party based on the multiple choice questions, or even text. Then a candidate based on the text. The text here is written by the candidates and given to the voting advice application as extra information. And then I'm going to recommend suitable words to be used in the text. Well, that's a funny application, yes, but you could think, for example, that if you're writing this sort of a text, you start typing in, and then you would have a list of words to be used in this style of text, like automatically. Let's see what happens. First, we are going to recommend a party based on the multiple choice question. Hanna told already you about linear regression, and this is an extension of it. So I have the question and answers. They are in Finnish. Let's not bother about that. But then there is the result of the predictor for the leading member of Vasemmistoliitto, the left-wing party, and the prediction of her party alliance. Luckily, it goes correctly in this case, and it also gives the probability of the prediction. So, if you have this sort of answers to the questions, the recommendation would be that perhaps a member from this party would be the point. Here we also see that it's not 100%. There might be some other shades to that. And if you take up the accuracy of the recommendation here, this actually recommends only, let's say, half and half correct. So 50% is the error ratio about. Is that bad? It's much better than random. But still there is an error. And this is the first lesson. When you do this sort of machine learning, statistics, AI, it makes errors. And you have to design things that tolerate them. Well, how did I achieve that result? I used R. We data scientists, remember, we often code, and we do prefer coding before this sort of data applications where you draw lines. We actually prefer coding. We are not superb on that. One reason maybe for not writing excellent code is because we have to balance in our training, first of all, between statistics and coding. The other thing is that we explore all the time. Here I show you that, for example, I have been interested in a certain variable in the data, and I just wrote a command and explored how it looks like, and there I actually detect that, oh, in the data there is the age of the candidates, and somebody claims to be over 400 years, or at least 400 years old. So there are mistakes in the data. We have to explore the data. The AI doesn't do that for us, especially if you are working with, let's say, old-fashioned databases in a company. You have to basically hunt down people and interrogate the people. What is this data about? What is this field about? Why it's coded like this? In order to understand what is behind the data. Because you know, data is not our primary target. Our primary target is to make decisions based on the data or make automates, that makes decisions based on the data. So we want to understand the world. And the data is a poor substitute for the world. It's poorer than the shadow there, even the big data, believe me. So this data pre-processing stage is something that is considered a bit dull often. You might have heard data wrangling or data munging. It is dull. It's like making configurations is for the developers. They wanted to code, but they have to make configurations. I heard that it's boring. But there is more than in this correcting the data, sorting out what it is, transforming it for the algorithms. Because that's the very point where the human knowledge for selecting the data, correcting it, and understanding it, and transforming it meets the kind of artificial intelligence, the algorithmic side. Because it's making this thing substantially defines the system together with the algorithms. So this data munging and wrangling is an essential part of understanding the data and the organization that produced it. It's a noble task. There is another thing about coding that I wanted to show. So maybe you have already noticed that I'm not a very good developer. But there is another thing. The code base here that makes the recommendations and the web application that shows them is around, let's say, 1,000 or a bit more lines. It's a small thing. But what I wanted to show is that the actual machine learning part is this. So just few parts, because it comes from a very well done package. And the point there is that this reflects also to the work amount on the projects. Let's say 90% of the work goes into transforming data, getting to know people, hunting them down, interrogating them about the targets that we want to achieve, about the data, what it means. And maybe 10% goes to applying good machine learning or statistic packages and making up the actual kind of magic there. Okay, on we go. Let's do big data. Well, not big, but at least natural language. Maybe that brings better results. So I took texts from the candidates, which are Open Data 2. There is text in Finnish. I have to do something for it to use a specific algorithm. So I count actually the words for each candidate. Then I make something fancy called lemmatization, which means that I get a dictionary form out of the word, and I just count the words for each candidate. I get a rather big matrix, which is essentially 0, but it in a way counts the words. What now? I could actually make the thing that I made before, try to recommend the party based on the text. And I made that, and guess what? The result was not as good. The error rate was far over 60%. It's still better than random, but worse like with the actual questions. Why is that? One thing is that carefully designed small data beats big data. So if you collect carefully data in a designed way, you beat kind of random big data. So the texts here they are kind of off topic in a way often. Okay, but let's go further on to recommending a candidate. Not this time by questions, but by texts. So I have the matrix of words, and what we often do in this case is that instead of making supervised learning that we used in the previous thing, where we knew some labels and the data, and then we made a machine that is able to connect these and predict a label based on the data. We are using something which is called unsupervised learning, which means that some features that describe the data in an informative way just pop out from the data. Sounds magic. Well, it isn't. In this case, I use a thing called matrix factorization, which happens to be here latent Dirichlet allocation. Sounds fancy, and the fancier thing is that it happens to be developed by Bly, Andrew Ng, and Michael I. Jordan, who are big names in data science. It's designed to find topics out of text. How it does that, we'll skip, but the point is that for each candidate we get now components. Let's say I picked 9 topics, and for each word we have the same topics. And that's merely a statistical process. Just trying to exemplify, let's say here we have one of the components and the words most associated with that particular component. For example, humanity, ethical, animal, unethical, and that sort of stuff. The other component here, I happen to know, would gain high values for Swedish words, because there are candidates writing in Swedish. And then there is some other topic probably related to urban things, and the other one related to countryside. The main point here is that the algorithm doesn't understand anything. It doesn't understand anything. It's a statistical creature. These things come up because of a clever design of the model, not because it would be somehow a subject that understands language. They are merely tokens. Let's go further. So I could also have a matrix that tells about the candidates. What are their association to these topics? For example, the leading member of a right-wing party is on the first line and has high values on one topic describing urban things, and also rather high values on the thing that we saw previously, the kind of ecological, global, environmental things. What I have done also is that I have now compressed the data in a format where it's easier to handle than the actual textual data. I can apply, for example, way of ranking the candidates so that their topic profile is similar to Mr. Orpos. So I could get a candidate recommendation system based on the topics, or you could also browse the candidates based on their topics if somebody had interpreted them. So these topics are interpreted by kind of professionals who know how to interpret them. The machine doesn't do that. What we do next is that we recommend a word, and I just explain how it goes. The recommending the words here goes so that you reconstruct the matrix back. We selected only few topics, and what it here does is that it compresses the data, it generalizes that. You might relate it, for example, to JPG image coding, where you compress information, then it smoothens the image while trying to maintain the kind of important things in the image. Smoothing here is good because it happens to provide us information on all of the words for all of the candidates, which is what words the candidate could use preferably in their text. Now, remember that this doesn't understand anything. These are just token, the words. What if we replaced the candidates with customers, say the customers of the Finnish broadcasting company, and the words, the tokens, with programs they have watched? We make a bag of programs. We have a count matrix of programs, and then we can estimate the probability that a user watches a certain program. And we have a real recommendation engine that is actually in use. It looks like this. So you go to the YLE Arena, the digital service of the Finnish broadcasting company. And if you have used that, it suggests you programs based on your and other users' behavior. Netflix does this. Web shops do this. This is called collaborative filtering. And yes, you can even get the components out. This is something which is not shown necessarily, and we don't have to understand even these components, but they just pop out from the data, so you can see that there is a component for historical programs, for children, for domestic shows, and so on and so on. But this sort of one algorithm, how fancy it should be, is just the beginning of our work. The algorithm was changed to that suits better this sort of data, and it can also take into account the time and the device, because there the recommendations differ, the optimal recommendations differ device and time-wise. But there is more than that. For example, this assumes that the world stays constant in a way. In reality, sports and news programs just pop up. They are sudden. And there are more popular programs at certain times, so the popularity must be taken into account. Another thing is that Wiley is a public service, so you have to have not just rely on blockbusters, but you have to create diversity to the programs. That's taken account with another branch of algorithmics. Then there is, of course, the cold start problem. What to do with programs which are new, no collaborative information. You have to rely on the content. How to rely on the content? Well, you could, for example, give some sort of meta description for the programs and relate them. Where to gain that from? One option would be to real AI, for example, transliterate the audio by AI into text and use the text as the content description. You have to monitor this sort of stuff. Maybe do A/B testing at least for a first aid to know what actually affects, how well it works. These are just algorithms, it's an engine. You have to have a process to show these to the customers, a user interface, UX design. This doesn't take care of that, nor does it take care of the architecture. I don't understand that much of the picture. When I joined Reaktor, I was merely doing applied mathematics and statistics. Now I can use Docker. I even know some Python in addition to R. I know GitHub. I have done things in AWS. But I'm not pro in that. There are back-end developers who are pros in that, and they are called sometimes data engineers. Anyway, somewhere there inside are the algorithms. And if you remember that I weren't perhaps that good in programming things, we need actually help from the developers a lot. We have to do teamwork. Speaking of which, the hype sometimes affects us and maybe even our colleagues. There are some troubles in our work. Perhaps one of them is the cargo cult, and then underestimating complexity. Let's start from the cargo cult. The cargo cult here means that if we just have big data, and if we have the AI, they somehow magically bring revenue and happiness to all of us. It's not that. It's hard work. There is integration, transformations, design, software design. You have to solve the right problem. And no one person can handle this, not even the data scientists. One thing in this cargo cult could be that I have often seen that a company hires a data scientist, and then there is a long list of things that are required. You should be developing new algorithms. For example, I have, after my PhD, never developed a new algorithm. There are plenty of them. I apply them because I know how to do that. But on the other hand, they should be doing some sort of strategic work, bring insights to the management board or whatever. No one person usually is capable of doing that, especially if he or she is recruited straight after master's degree. The expectations are too high. There is no one person who can do that sort of thing, at least directly from the school bench. Which relates to underestimating the complexity. There are lots of moving parts here. And the information is a bit like money. It flows through the organization. It flows from the customers to databases, to data scientists, to management. Maybe there is a feedback loop so that you do recommendation engines, artificial intelligence, you record how it affected to the persons and this sort of stuff, make experiments even, collect new data. It's a complicated thing, and the information does not read the hierarchical organization chart. It doesn't care about that. So you have to organize in this work along the information path. The teams must include members who actually do these things, the business people who do the decisions, the data scientists, the developers, and DE engineers. They must work in the same team, and communicating through management reports is not making things together. What's fear? The fear is that we don't use the results. The other thing would be that we are somehow trying to make the director happy, that we provide results that he or she might twist according to the vision. We should be truthful. The fear is also conforming to unethical use of data. I'll give a brief example about why the unethical things might be closer to us than we realize. You saw the party classification thing. What I didn't tell is that if I added the language, and yes, even the religion of the candidate, because it was provided on the consent of the candidates, I could get much better classification results. But if you used language, gender, not to speak about religion, in your machine learning or recommendation system in general, that might become illegal. Not to mention the fact that I could have done a system that where you can grab a text, put it in, and use this machine to predict the party. Well, it goes wrong in many senses, but it's essentially questionable whether you should be doing that sort of stuff, that you grab people's information and predict, let's say, political things without consent. So even when you use objective statistic, you might be ending in doing things which are wrong. And who knows about that better than we who are actually working there in the front line doing these things? So there are ethical questions that we must take into account already. Why is that? That is because machines multiply things. If we do bad design, bad ethical choices, that might gradually lead us to, let's say, dystopia. If we make good design, maybe we do something better. Okay. Still one thing, some examples of the design, just to remind you. You probably saw that I recommended programs. That's kind of safe thing to do. I mean that if you recommend a wrong program, maybe it's not that dangerous. But what if I had recommended something based on the prediction of gender or something like that, the old-fashioned way of making marketing? If it goes wrong, the people might become offended. Why do you make such a claim of the gender? So you must design things that tolerate risk. Another thing about design is, for example, that you have to be able to combine things. If you recommend grocery things, use grocery data, the machine does not understand that marketing tobacco in Finland is illegal. People buy them, so it would recommend them. And the most common thing that you buy from a shop is often the plastic bag. Our AI doesn't understand that. It would recommend a plastic bag. That's silly. Recommending tobacco is illegal. You might be surprised. I tried to explain this once, and I had really hard times of explaining that somebody must make the decision what to recommend and what not. So, I'll stop here, but just remember, AI is not magic. It's done already. We do these things on daily basis. It's not magic, it's understandable thing. You can learn it. Everybody should learn it a bit. Because we won't make the AI in any other way than making it together. Thank you.
All right, thank you. Let's move on to some questions. Maybe we can start with something from our message board.
Yes, we got some questions to you, Johan, here on the message board. Let's start with this one about what makes you lose your sleep. So, Johan, what recent progress in AI has made you lose your sleep?
The recent progress in AI has made me lose my sleep. Well, I have to say none. I lose sleep for various things, but not for this. Okay, let me think of something. One was perhaps the fact that the data is used in ways that are against legislation already now. So people, in a way that we already have done things what should not be that done. And it pops now up because of AI. It should have popped up much earlier, because you can use data unethically even without artificial intelligence. So it's not that much about AI, it's about evil people.
Fair enough, I think.
Thank you.
Then I'm not sure if we have somebody with a microphone for audience questions, because I don't see any. Well, if we don't, then you can always shout it my way and I can make sure to repeat it. Are there any questions for the audience?
There is one.
Oh, okay, I'm going to have to listen very carefully if that's... All right, so maybe to repeat, mathematician starting to learn R, the documentation is horrible. Does it get better?
I know your pain because I hardly ever use the help within R. I Google up things. It's because it was originally meant for statisticians. So I have background in statistics and machine learning, and I have hard times in understanding for a function, for example, the examples, how to use the function. The best way is really to Google up. And for example, if you saw, I used an IDE from a company called RStudio. They have done pretty much work on the documentation too, at least made software to help that. So I have to answer that's a known problem.
Right.
I don't know whether it gets better or not.
All right, more feedback to explain that.
Yeah, well, well, I'm just a poor user
Right.
of R, so let me put it this way. It might be more fruitful if the developers, for example, took up these things, because there are developing teams developing R also, especially, for example, for the new packages and that sort of stuff. So this is basically the problem that I was talking about. There are silos of data scientists, statisticians, and developers, and that's pretty old-fashioned in a way. So it's much probably more to the point if developers take up these things,
Right.
if you really want to use R, so that it becomes a decent programming language and environment.
Okay, that makes sense. I think we have about time for one more question. Do we have another one on our board?
Yeah, we just had some new ones. This one is actually not paid, I think, but Johan, can you recommend the Elements of AI online course?
That's something that slipped from my speech because I was about to recommend it. So the point is that I'm very happy that I have been taught by developers and designers things how the software and projects are actually done. What is CI? Why it's important? What is actually making agile things? I didn't know that. I'm a researcher from my original background. So on the other hand, this is not magic. Some things require a bit concentration if you want to understand how the algorithms work. But the elements are really something that everyone can grasp. And what is the best way to make to work together would be that the developers would know what is AI. The designers would know what is AI and what these algorithms are for. Then we can communicate much better. And there are cases where you can do AI or machine learning yourselves. Many of the algorithms is things that you just put on the place when you know what you are doing. You don't have to care about the maths that much, or any of that, basically.
Yeah.
So it's not magic.
All right.
It's tech.
Clear. I think that's all the time we have. We'll be continuing again
10:30.
10:30. So
10
yes.
minutes.
Okay. Thanks again to Johan.
Thank you.